Let x be a continuous random variable for which the probability that x is less than 5 is 0.7, and the probability that x is less than 2 is equal to 0.4. What is the probability that x is at most 5? Well, the first thing to notice is that the probability that x is less than or equal to 5 is the probability that x is less than 5 union x equals 5. But these two events here are mutually exclusive. And that means that the probability is the sum of the probabilities individually. But the second guy is 0 because we're dealing with a continuous random variable. And so the probability that x is less than or equal to 5 is the same as the probability that x is less than 5, which is 0.7. How about the probability that x is greater than 2 and less than 5? Well, we can split this up into the probability that x is less than 5 minus the probability that x is less than or equal to 5. Less than or equal to 2, I apologize. But using the same argument as in part A, we can get rid of the bar underneath the less than or equal to sign here, this bar here. We can get rid of that. And now, using our given information, we get 0.7 minus 0.4, which is 0.3.